Welcome back everyone. We hope we are refreshed and ready to another session. Let us now felicitate our eminent speaker, Dr. Gautam Bandyopadhyay, retired professor in the Department of Management Studies, National Institute of Technology. To do the honor, I would now like to invite Dr. Rajiv Roy, Principal of BCRAPC, to kindly come forward and felicitate our esteemed speaker with a token of appreciation and gratitude. Please, sir. It's my distinct honor to sincere pleasure to introduce today's esteemed speaker, Dr. Gautam Bandyopadhyay, retired professor in the Department of Management Studies, National Institute of Technology. He has completed his PhD in Management Studies from Durgapur University. He is AICWAI and FCMA. Qualified from ICWAI and also graduate in Operations Research from Operational Research Society of India. He completed postgraduate diploma in computer application from Regional Computer Center, Durgapur University, India. His research works are published in numerous foreign peer-reviewed journals, Indian peer-reviewed journal. He has successfully guided 20 PhD scholars. His research mainly involves with financial capital market and portfolio optimization using different soft computing techniques such as fuzzy goal programming, fuzzy time series, different statistical multivariate techniques and optimization techniques like DEA, mainly used softwares like Python, SPSS, Jamovi for statistical analysis and RStudio for statistical as well as optimization techniques and Python for machine learning and visualization. He will now discuss about research methodology using application softwares. Please, sir.
Well, good afternoon to all of you. So really it's my great pleasure that after retirement I am getting the chance. Yeah. So actually my topic was initially when decided, then the topic was that is the data visualization using Python. The problem is, if I start Python now, it is very difficult to understand. So what I am thinking, if we start like this way, then why visualization is needed? That will help you actually. So if you ask me, what is your favorite number? So I always say tell 5. Always I tell 5. So question is why 5? Because 5 is first of all is the prime number. And 5, in case of mathematics, there are 5 fundamental numbers. So in any mathematics, 5 fundamental numbers, 0, 1, E, I, Y. So these are the 5 fundamental numbers. Why is this fundamental? Because with these 5 fundamental numbers, we can create anything. We can solve calculus, we can computer is based on this. Nowadays we are doing machine learning, AI and so on. Everything based on these 5 fundamental numbers. So that's why these are called the 5 fundamental numbers of mathematics. Next 5 is, what are the 5 fundamental numbers of statistics? Also similarly, 5 fundamental number is when you get some data, and from that data easily you can find what is the maximum value and which is the Q3, Q2, Q1 and Q2. So these are also 5 fundamental numbers in mathematics, in statistics. So question is why this is called the 5 fundamental number in statistics, because basically statistics divided into two parts. One is the parametric part, and another is the non-parametric. And maximum data set involving the machine learning, maximum machine learning optimization. These are the non-parametric data. And when it is non-parametric data, so it is not based on parametric. And definitely for the non-parametric data, it is completely the distribution free. You will not get any distribution. So then we find only the 5 numbers. That is what is the maximum value of the data, minimum value of the data, what is the third quartile, is the Q3, Q2 and Q1. So then again 5. Now if you ask me, sir, I want to know nowadays AI/ML I want to know some information retrieval subject, I want to know some artificial intelligence, so many things. So I am telling you, it is also based on 5. So you ask me why 5? Because to know this, AI, ML, deep learning, we have to know statistics. So number 1. Second thing, we have to know linear algebra. That is the second. Number 3, we have to know calculus. Number 3, we have to know probability. And then finally optimization. So again it is 5. So now come to the point, say if we start my machine learning or deep learning, anything conceptual learning. So again it is based on 5. Why 5? Because first of all, when you get some data, first of all we have to know the D part. D means the descriptive part. That's the first D. And after getting D, then we have to know diagnostics. Again D. So after diagnostic part, we have to know the prediction. So we go for the different type of predictive model. So nowadays we are learning, there is a machine learning, so on. I am telling you, in some lectures I told, the basic thing is if you know 11, 12 maths. If you know 11, 12 maths, you can do anything. Because everything based on 11, 12. And now we are studying just simply the extra part. But the base fundamental is 11, 12 maths. Question is why? Because basically in total mathematics, there are basically 6, functions, basically. One is the algebraic functions, one is the trigonometric functions, one is the exponential function, logarithmic functions, inverse function, another function is the hyperbolic function. So this, and just if you think of it, everything based on this. So that's why calculus started. Okay. And now why we need statistics? Because without statistics, because just you remember only 4 words for learning statistics initially. So what are the 4 words? So you have to know what is the meaning of population. It's very important one. And what is the meaning of parameter? What is the meaning of sample? And what is the meaning of statistics? So these are the 4 words. And on the basis of these 4 words, we are doing this. Because question is why? I am telling you, if you ask me one question, just nowadays AI, ML, why? So I am giving a simple answer. If I would, at the time I will show you the presentation of the ML. That say I have some data set, and for the data set, I like to predict something, and predict a regression line, or say logistic regression, or anything else. And then we get some model. Now the problem is, when you get the data, this is the real problem. When you get the data, we don't know anything, no pattern. And we are solving only the linear regression equation. We are solving only the logistic regression. And the definitely error is more. So now the concept of machine learning started. Machine learning said, better you take the help of artificial neural network. You take some iteration method, you take some gradient descent algorithms, you apply this thing and try to minimize it. And you learn the machine. What they are doing actually? Basically, they are doing statistics. Why statistics? They are basically doing bootstrapping method. Basically, they are doing the bagging method. Basically, they are applying different types of k-fold validation method. Basically, they are doing so so many methods they are using. But the problem is, you can tell me just first initially try to tell them what the problem, then I go for solutions. But the problem is that when you go for estimation of something, we are getting error. So very interesting data set I am telling you. Maybe today I could not show it because it is not in my laptop. There is a very interesting data set AICTE established in 1976. There are 4 sets of data, very interesting, except some values of y and some values of x. And for each set, we find the mean, we find the standard deviation, we find the quadrants, everything we find. We find the correlations, we find the regression coefficient, and for each data set, all are same. This is really interesting, all are same. Then the question is why? Then, how we solve it? So, when you visualize the data set in the graph paper, we check that one data set showing the linear trend, one data set showing the exponential trend, one data set showing the logarithmic trend, and so on, but their results also. And that is a very interesting data. So that's why problem is, when I started my journey in my academics, because I am the student of mathematics and statistics, always I am thinking some data I am using, putting the software, and we are getting the results. And now there are so many ChatGPT, they are giving the results. But the problem is, when I get the results, when things the interpretation from my domain. Okay, say I'm giving a very interesting thing. Suppose I have some data, and we get a model, and on the basis of model we can predict the future. That is the basically prediction. And after prediction, there are some very huge difference between the actual values and the predicted values. Huge difference in the actual value. And that is the error is more. So now I can ask you, because you think of it, it is an interactive class, how you can minimize it. Again I am telling you, I have get some data and put in the software, any software. And we get the value of R square and so on, adjusted R square, so many things. But after predicting, we are trying to find, is there any difference between actual data set and predicted data set? And we check that there is a huge difference. So automatically you will ask the question, how you can minimize it? My question is clear. But in the research paper, if I am telling you, in the research paper, if you write down only the limitations and try to give the answers of the limitation, say there are, for some model, say there are 20 limitations. Then I am writing this is the answer of the limitation 1, this is the answer of the limitation 2. In this way I have finished my paper. I am giving the guarantee your paper published in the journal. Because what we will do there, in the paper, we collect some sample. Maybe it is the primary data or the secondary data, or maybe the experimental data. And on the basis of sample, we try to predict a model. And after predicting model, since this is the AI/ML age, we try to validate some model with some techniques. And this is my paper. Maybe paper published in a good journal. But nowadays, the problem is it is the AI/ML age. So always the reviewer will think of it, how to minimize error. They are only thinking, okay, oh no, R square is 60%, 40%. So definitely it's not good. Because nowadays the AI will saying, try to go to the 90% minimum expectation. So this is the real problem we are facing. And I am telling you, very interesting research paper I have shown. I will not tell the name, in AICTE Durgapur, not in AICTE Durgapur, everywhere they are doing. I know some classification techniques. Now you can ask me, sir, what are the classification techniques? There are so many, started from decision tree, then logistic, discriminant, suburban machine, entropy, Gini's coefficient, so many classification, random forest. Okay. One student, what happened? Solve all classification formulas, all, one by one, for the same data set. Data set is set, solve 11 to 12 classification problem. And that is his or her research. Then I asked, is it a research? You solve only 12 methods, and then you tell that this is my best method. This is my best method. And my question is, initially, on the basis of a single method, why we cannot say? And if we cannot say the single method is failed, then we can think of it the other method is there or not. But initially what we have done, you solve all methods. And then, okay, this is my best method because R square is very high, adjusted R square is very high, and F is very high. These are called, very interesting thing. When you go for any statistical analysis, always think of it. There are two types of fitness tests. One is called goodness fit, another is called badness fit. So what are the goodness fit? One is R square, adjusted R square, and F. And always you concentrate on F statistics because F is called the global test statistics. And now you come to the part badness statistics, badness fit. What is badness fit? Your AIC criteria, SIC criteria. So this is the real problem. If we think of it, I know all methods and apply all methods, we are getting the result. I am telling you, I am sharing my perception, and that's not a good research. Good research is that you solve some method, you find the limitations, and how many limitations in the method, then you try to solve one by one. I am telling you why, very interesting thing. Why we are not getting a good results? Say we get the data and plot in the graph paper. Because when we plot in the graph paper and we visualize, the problem is there are so many outliers in the data sets. Outliers in the data set means there are so many extreme good values and extreme bad values. And if you ask me, if there is outlier and there are so many methods for getting outlier, we try to omit the outliers. But after omitting the outliers, definitely we get a good model. The question is it not a research? So my question is, with outliers, can we get a model? Now I am giving a simple example. So in the stock market data, there are so many outliers. There are so many extreme good values, extreme bad values, poor values. And I like to predict the stock market with outliers values. Is it possible? The answer is no. Answer is simply no. We are trying to apply some methods by which we can get some result. This is our approach for getting the research PhD. We are applying this approach. Okay, some papers, a research paper we study, again apply some method. In this way apply. Another thing I am telling you, why it is happening. Already I told you, in my first session, Subhash already told about the non-parametric data. Mainly, the problem is the data set is non-parametric. Why non-parametric? There are so many outliers. So many outliers. And since so many outliers, that definitely if we plot the data on the graph paper, it is not a linear. It is not a linear. It looks like a non-linear functions. And if it is non-linear functions, really it is difficult to predict. So then question is, now if you study, I am telling you, now the research is going on only non-parametric. There are so many MCDM criteria developed, but no method is the robust. Question is why? Because MCDM basically on non-parametric. And now the study started. They started with only the two variable y and x, and there are some researchers coming on multivariate non-parametric. Because mainly we are solving multivariate parametric, like we are solving multiple regression, we are solving logistic regression. So these are called the parametric multiple variable. In case of non-parametric, it is very difficult if there is one dependent and more than one independent. It is very difficult. So in the last year I am trying to solve some non-parametric method using the kernel regression, kernel equation. And you try to check, suppose you get some data set, I am telling you, you get some data set, and with the data set you go for all-time descriptive analysis. Now what is descriptive analysis? That is divided into two parts. One is the parametric descriptive, another is the non-parametric descriptive. So what do you mean by the parametric descriptive? And definitely when you start your research, you start with the univariate data. Univariate data, then go to the bivariate and then multivariate. So it is completely the sequential process. And when you go for univariate and divide it into two parts, first part is the 4-point summary and second part is the 5-point summary. This 4-point summary is the parametric summary. What is the 4-point summary mean? Standard deviation, skewness and Cartesian. These are called 4-point parametric summary. And what is the 5-point non-parametric summary? The maximum value, Q3, Q2, Q1 and Q2. So this is overall, this 9-point summary is called our descriptive analysis of the univariate variable. Now after getting this univariate concept, you go to the bivariate. I am going for the sequential process. When you go to the bivariate, that means there are two variables. And from your domain knowledge, you have to know that this is my dependent variable and this is my independent variable. From your domain knowledge. And applying your domain knowledge when you know, so definitely you start with two variable concept and try to know. I am telling you, I have one my teacher, I am telling him godfather of my life. You know the name, Professor Gautam Bandyopadhyay. So one day I told Tafada, can you tell me, if for knowing so many machine learning, so many AI, which things at least you have to know? Tafada just told me, initially, Gautam, you have to know only the descriptive statistics and then the correlation regression. Because everything, machine learning based on this thing. If we don't know regression, so how we start machine learning? And I am telling you, one of the author, very interesting author, as from the Madras University, has written a book only on regression, 700 pages. So it's my request to all of you. So before starting anything, you study only regression. So if you ask me, these are what are the types of regressions? This is a real question. The types of regressions, I am telling one by one. So number one, basically there are two variables, simple regression. If there are more than two variables, multiple regression. Then if there are, one dependent, more than one independent logistic regression or discriminant analysis, support vector machine learning, what are they? All are regressions. All are regressions. Number three, you are coming, this regression not working, then you go for the principal component regression, PCR. PCR not working, then you go for smart PLS regression. So, and then in case of some regression, that is called hierarchical regression. So, I am telling you, if you want to think, I will write only paper on regression. So, how many regressions? So, I am telling you, before starting my non-parametric journey, still I am in the learning, because this is a huge case, non-parametric.
Sir, can you please elaborate the concept of parametric and non-parametric?
Can you elaborate? Actually, if you ask me what is parametric, then I am telling you, suppose I have a data. Okay. Can I write something?
Yes.
Say, I have a data, say, very interesting data, 20, 30, 40, 50, 60. Suppose this is the data. So without any software, we can say this is a parametric. I'm coming. Without any software. Question is why? When you get the data, you always arrange the data in the increasing order. is the number. Increasing order means minimum, maximum, and the values. And what is the interesting part is, for this data, they are mean equal to 40, median also 40, Q1 equal to 30, and Q3 equal to 50. So initially I started my lecture form with the 5 values. I have taken 5 values. And from these 5 data, and we can give the 6-point summary. So what are the 6-point summary? 6-point summary is the minimum, Q1, mean, median, Q3 and max. This is called 6-point summary. Okay. But problem is, if I am taking another data, this is another set. This is a very interesting fight. But problem is when you increase the number of observations, and not only the number of observations, this is very large observations, which occur in the case of stock market. And when you get these, so we get mean that X bar equal to 50. And definitely median definitely lies between 6 and 8, that is 7. A huge difference between mean and median. We problems start. So that's why when you get data, you find the right point summary. And if you check, there is a huge difference between mean and median. Huge. Then another very interesting thing, that now I am taking another set of data, that is 20, 35, 40, 45, 60. This is another set of data. Another data set. And from these two data sets, just to check, mean and median are same. And minimum and maximum are same. But the problem is, two data sets are not same. And if you find the skewness, that is also you get 0. You get 0. Very interesting. But if you compare, then you can say according to the stock market concept, so this data set is good. Why? Because we find another parameter, that is standard deviation. And if you calculate the standard deviation for the first set of observations and calculate the standard deviation for the second set of observations, I am coming to your answer, second set of observations, and then you can check easily that standard deviation is less in case of this, the upper set. Obviously, standard deviation is the parameter. Because we are using this. Now I am telling a very interesting thing. Say I am considering the data from 2 companies. The 2 companies' profit for the last 5 years. The year 1, year 2, 5 years. And using statistics, I will try to compare which company is good or bad. So what are the parameters? 9 methods. We apply mean, but by chance mean are same. Maybe both the mean are same for the 5 years. Then we calculate standard deviations. By chance both the standard deviations are same. Then one parameter left, then you go for skewness. What is the departure from the symmetry? And by chance the skewness is same. Maybe then only one option is left, that is the kurtosis. And kurtosis is basically, called the bigness of the tail area of the distribution. Kurtosis is also same. Then what is the decision? All observations of the companies are same. And that's why there are no other methods. So in some seminar, workshop asked me, why for the parametry we are using mean, we are using standard deviation, we are using skewness and kurtosis only, that why not the other thing? It's a real question. Why not the other methods? Because the answer is very simple. Because mean is the first degree polynomial. Standard deviation is the second degree polynomial. Skewness is the third degree polynomial. And kurtosis is the fourth degree polynomial. And if you check all mathematics, beyond the fourth degree there is no methods. And if there is a fifth degree polynomial, 16-degree polynomial. So naturally some software solve the 20-degree polynomial for getting the eigenvalues. They are using the trial and error method, numerical analysis. But not the direct method. What is direct method? For the second degree there is the 3 Siddhanacharya, third degree Cardinal's method, and fourth degree Faraday's law. That's all. Same thing applying in statistics. So with the help of first degree we are finding mean. With the help of second degree we are finding standard deviations. We are finding with the help of third degree we are finding skewness, and that is the real problem. When if I beyond of this, if we get the data, there is a huge difference between mean and median. Your question. Standard deviation is very high. Skewness is very high. Suppose for some data set, skewness is plus 50, maybe. It is possible for stock market. Kurtosis is very high. Then you can easily write there is no distribution. That's why it is completely non-parametric data. Non-parametric data means there is no distribution. Now you can ask me, sir, what is distribution? So definitely when you get some data, that data is repeated. Some data is repeated. I am telling about the last sample. So when a data is repeated, so then the frequency comes. And when the frequency comes, then the probability comes. Because the probability is established on the basis of frequency distribution. So then, very interesting, and from probability, we try to find the distributions. Now you can ask me, just what type of distribution? So distribution divided basically into 2 parts. One is the discrete distribution, another is the continuous distribution. And we know which is countable finite and countable infinite, that is called discrete distribution. And this is very interesting because I am telling you, if you want to know statistics, so there is some sequencing process. So what's the sequencing process? First we have to know the descriptive part. So you can ask me, sir, why do you want to go for the descriptive part first? This is a real question. Why you go for? Because descriptive basically meaning is the summarization as well as the visualization. So if we don't know the summarize the data set and visualize the data set, how we go for the next step? So first thing is always when you get the data, first summarize the data and visualize the data. And this summarization, I am telling you, this summarization basically 9-point summary. Because 4 points for the parametric, already I told you. I am coming to the next point. So, if you ask me, already I started with the 5. So, how we can define 5 in my data analysis? The first part is the descriptive. So, for telling, I am telling a story. Then you will understand why 5 is important. Say, I have some disease. I am the retired person, I have sugar, pressure, everything. So, after 1 month, I have to go to the doctor for the checking. Okay, I went to the doctor. So what doctor? Definitely doctor will ask me, can you tell me what is the problem? So I have to listen. This is my, this. Then doctor try to diagnose. Then the doctor will try to diagnose which is not correct. That is basically the random diagnosis. And after random diagnosis, doctor tried to predict some disease. And when doctor predicted some disease, there is also some error. There is some error. That's why in case of prediction, there is some error. So after prediction, doctor thinking about, you now have to write a prescription. That's why the last piece is the prescriptive analysis. Because write the prescription. Because confirm the disease. And now after prescription, nowadays the problem is due to the chronic load. Huge chronic load is there. So then doctor going for cognitive analysis. Total the qualitative study. So that's why what is my 5 letter? That is the DD, PP. So if one by one you have to study. So first you have to study the D part. D part means everything.
Slipper means
Descriptive.
descriptive.
Second B part is the diagnostic. P for predictive. Next P for prescriptive and last P for cognitive. So, first of all, again I am telling you to know these things. We have to know, number one, what is the univariate? We have to know what is the meaning of univariate and single variable. Single variable. And then you have to know what is the bivariate. And then finally multivariate. So for these, say I have a data set, X, then you can get your result. Data set, say X equal to 2, 4, 6, 8, 10, and Y 3, 5, 7, 9, 11. Just you tell, we get a model? Can you get a model? The model is nothing but the relation. Model is nothing but the relation between X and Y. Am I not right? So obviously, we can write that Y equal to X plus Y.
So Y
it's a
product-
linear model. Now we can ask me, just sir, can you prove with a simple mathematics why it is linear? My question is clear. So what will do that? Simply go for del Y. Discrete change in Y. And when you get the del Y, you get 2, 2, 2. All are uniform. And when it's all are uniform, go to the second order. So all are 0. So just try to remember our 9, 10, 11, 12 class that if Y equal to mx plus c is a straight line and this d over dx, change of Y with respect to change of Y equal to constant like this. So we can easily say it's a linear. So when you get data, it's my request to all of you, when you get data, simply go for first order, second order, third order, fourth order. Then you get the idea that why the error is coming. Because what we are doing, we are not doing this. We are directly go for regression. And definitely after doing regression, if we check this is my error, why error? And that's why error is coming. Because initially if we find error, say I am giving the data x equal to 2, y equal to 9, 4, 2, this is 50, 70, 90. Can you get a model? No. Because if you find the del y, del square y, no convergence. So definitely after 4 values, since there are 5 values, in case of 4th degree polynomial, we get the convergence. I am not doing this because it is a complete mathematics, but very interesting. When you get the data between x and y, simply go for differences. You get the idea. Okay. So this is the first piece. And second thing is that say I am giving a very interesting example, that is systematic blood pressure. Very interesting example, systematic blood pressure. depending on cholesterol level and age. Simply domain, I am applying domain. The systematic blood pressure is a function of cholesterol coma age. The function means this is the dependent variable and this is the independent variable 1 and independent variable 2. What is the advantage of machine learning? Advantage of machine learning is that we can take a very small sample. Question is why? Because if we take a very small sample using so many techniques like the bootstrapping, bagging, and with so many random number technique, we can generate the samples. Okay, Python, they are writing the code, so many, 1 lakh, 2 lakhs numbers are generated. But the question is, suppose I have taken 6 values, only 6 values of systematic blood pressure, 6 values of cholesterol, 6 values of age. And from my domain we know, if your cholesterol level increase, blood pressure increase. And if age increase, there is a chance of domain. Now I try to prove with the empirical. Now what problem I am telling you? Because today already I told you, I tell the only problems. Then I will go for the solutions. So what the problem will face, that very interesting. So definitely the correlation between systematic blood pressure, already you know correlation. That's why I'm used without concept correlation, you know. That is the systematic blood correlation between systematic blood pressure and cholesterol level must be positive. Am I wrong or right? Must be positive. Similarly, cholesterol level between systematic blood pressure and age also positive. Clear or no? Also positive. But why machine learning? Then you will understand. But if we solve the problem using our conventional regression technique, conventionally we check that means this is our model. SVP is equal to constant plus beta 1 into cholesterol level plus beta 2 into age. This is the model. Simple, this is the model. And you solve this model. And you know that is mathematics least square method. That you know. And using the least square method, we get the value of constant, we get the value of beta 1, we get the value of beta 2, that we know. But unfortunately, in some cases, from the domain we get, there is a concept is called correlation matrix. Correlation matrix. So what is the correlation matrix? Now 1, R12, R13, R21, R22, R23, R31, R32, and 1. So this is the correlation matrix. And we check that from the correlation matrix, SVP and cholesterol level is positive. SVP and age is positive. But when you go for the regression, the coefficient of cholesterol level is very problem starts. Then the problem starts. This is the limitation of conventional regression. And that's why you take that approach. Because definitely we have to check it. So for checking this, first we apply PCR, that is the principal component regression. we apply this. Today I will not discuss, don't mind, because if I start, it will take a huge time. Huge time. PCR is a topic. It takes at least 3 hours to discuss. Okay. But I am telling you, for the PCR, you check that and this coefficient is positive using PCR. And when this coefficient is positive, then the question is, since this is a multiple regression, we get R square. We get R square, since it's a multiple regression. And when you get R square, means definitely what is R square? Now how much the variation of the dependent variable can be explained by the independent parameters. So when you get this R square and say R square equal to 0.7, so still and we are not satisfied, because still there are 30% error. So now we apply some machine learning technique. Machine learning technique, learning. Simple learning. And after learning, at what level it is converges to. So after learning, we apply the smart PLS regression. We check that beta 1 positive, beta 2 positive. Not only that, this R square is more than this R square. Now question is, say we are getting R square, say 0.80. Clear? 0.80. Still 20%. Still 20%. How do you do that? Now we apply. Initially we started with the 6 observations. Already I told you, there are 6 values of y, 6 values of x1, 6 values of x2. So then apply what the softwares are doing, machine learning, Python, R, any machine learning software doing. What they are doing? They are doing, apply the simple random sampling with replacement. Simple random sampling with replacement. So definitely you can ask me, yeah, what is that? And definitely I'll explain it, a very simple example. And with this, we can generate 6 to the power 6 data set. 6 to the power 6 data set. So can you think of it? 6 to the power 6 means, 216 whole square. So near to 40,000 data. 41 or 42,000 data. So we generate this. Question is why in some data sets they are repeated. And what the machine learning doing? From 66, they are taking say only 1,000 data set. Software, when you run the software, they want what is the limit? You are giving say 1 lakh data. In case of deep learning, you can give the 10 lakh data. Simple, I am telling you, without statistics, nothing. Without mathematics, nothing. Seriously speaking. Because you are simply apply the Excel. Okay? And after applying, they are, after training, what is the objective? How to make the R square high. Am I wrong on that? So they are doing these regression techniques. Now next question is, now you can ask me, then why these types of problems occur? This is the real question. So I am trying, are you feeling bored?
No, interesting.
Huh?
No, sir. Interesting, sir.
So now why these are happening? Why these are happening? This is a very interesting thing. Say, if we discuss about model, we are basically our discussion predictive model. So model divided into 3 parts. Any model. You can think of a supervised model. You can think of an unsupervised model. And nowadays, those who are working in the perfectly machine learning, so they are saying reinforcement model. Okay, that part today I will not touch. So basically, model is independent model. Model is hypothetical model. And model is saturated. Saturated. So these are the three types of model. Now you can ask me, sir, what is the meaning of independent? What is the meaning of hypothetical model? And what is the meaning of saturated? So I am telling you a very interesting thing. So I am giving simple example. Suppose I have one dependent variable and 20 independent variable. One dependent variable and 20 independent variable, and I try to fit a model. And then we apply mathematics first. Then I will tell you what is the problem of mathematics and how we can solve using statistics. But statistics also derives from mathematics. Very interesting. So if we go for mathematics, mathematics will give you that you have to estimate 2 to the power 20 parameters. This is mathematics. Why mathematics? Because out of 20 variables, maybe no relation with any variable. Out of 20 variables, relation with a single variable. Out of 20 variables, the relation with a two variable. And so on, 20 out of 20. So it is nothing but 1 plus 1 whole to the power 20. Binomial theorem. And it is nothing but 2 to the power 20. So 2 to the power 20 is derived. And when 2 to the power 20 is derived, so its value is 10,48,576. Will be within bracket, you can write that. If you go to any Google, any presentation, they are giving the example of 20 variable and 30 variable. Crores scores. Because that is mathematics. Now we apply statistics. Statistics told us no need to think about more than 2 variables. You go for pair. Pair means you go for x1, x2, you go for x1, x3, you go for, that's why the correlation matrix started. That's why covariance matrix started. Correlation matrix, covariance matrix always pairwise. And you will be astonished, when you go for pairwise, then it creates only 2, 1, 1 models. Because why 2, 1, 1? Because we calculate only no relation with single variable and 2 variables. Am I not right? Huh? And that if you calculate, we get 2, 1. Because this is 1, this is 20, and this is 190, and naturally we add 1. But problem started again. Again problem started. If we have to estimate these 190 parameters, then the model is not independent. Because in case of regression, the first assumption is all variables having no multicollinearity or some multicollinearity can occur.
What is the meaning of multicollinearity?
Multicollinearity means correlation between the variables, between the independent variables. Say, why in case of the last problem, when the cholesterol age, age increases, cholesterol increases. So there is a high correlation between these two. That is the case of cause of multicollinearity. And this problem will occur, principal component regression, smart PLS regression, machine learning we are using due to multicollinearity. Multicollinearity is very, very important. Now, I am coming next part. Up to this okay or no?
Yes.
So this is the independent one. So naturally, my problem started from independent and moved towards the hypothetical model. So in case of hypothetical model, we can consider some multicollinearity because that is called the predictive model. So there are two types of model. One is called exploratory model and one is called the predictive model. In case of exploratory model, we will not consider multicollinearity, fully independent. But in case of predictive model, we have to consider some multicollinearity. So naturally, when you consider some multicollinearity, it approaches to hypothetical model. And when huge multicollinearity occurs, then moves to model is saturated. So when model is saturated, there is a very important term in statistics that is called degrees of freedom. Very important. I am telling you, there are two terms you try to remember. One is degrees of freedom and one is the p-value. Degrees of freedom, another is the p-value. What? P-value. Okay, I will come. First of all, you tell me it is clear. So again, repeat, independent means degrees of freedom is very high. That is the number of independent parameters. Degrees of freedom is very high. When it moving towards to hypothetical model, degrees of freedom is decreasing. And when it's moving to saturated, then degrees of freedom is zero. So in any model, if the degrees of freedom is zero, that means a completely bad model. Remove this. So always now question is, why degrees of freedom is important in total statistics? I am telling you two things are very important. One is the degrees of freedom, another is the p-value. Definitely, then I know you know probability, you know distribution, everything you know. But still, the two things are left. That is the degrees of freedom and p-value. So now I am coming simply, what is the meaning of p-value? Say, suppose I have some data set. Very interesting example. I have some any data. Mainly, if you go for the stock data, you will face a real problem. And this is my, say, X bar. Why X bar? Sample mean. Now, but I don't know the mu. Mu means population. I don't know, because population is very large. Population is very large. And since the population is not known, so we take the help of this thing hypothesis. I am giving, say, X bar. I am giving a simple example, I hope then you can understand. In the class, say total population is 20. And since in the class I am also present and my age is more than 65, so automatically X bar equal to say 45. Very interesting. 45. Because I am the outlier. I am the outlier in the class. So when we take the X bar equal to 45 and now exclude B. Excluding me, sorry, this is population mean, and exclude me, bar equal to say 30. So there is a, so when I am excluding mean, obviously somehow. Not to all populations. So, what is the difference between x bar minus mu? That is the sample minus population. That is the main objective in machine learning. They are thinking the sample statistic is approximately very interesting in the numerical analysis. In numerical analysis, there is a theorem called Wester's theorem. The Wester said that if you think of it, 5x is the total population and fx is your total sample. So what is your objective? That 5x minus fx modulus must be less than epsilon. That is machine learning. That machine learning will. And that's why they are going for bootstrapping method, they are going for bagging method, they are going for different validation technique, careful method, there are different, LWCP method, there are so many random number technique methods. Only for this. Because their objective is how to make this difference less than epsilon. And error is tends to 0. Limiting sense. That's the main objective. So these, on the basis of this, we can create the p-value. Why? Say, if you get that your x bar minus mu modulus equal to 0, can you tell me what is the meaning? That is sample mean and population mean are same. More or less same. Now if it is more or less same, now what is the probability of this? We certainly accept. Certainly accept. Because your sample mean equal to the population mean. And definitely this probability equal to 1. Clear? When the p-value will be 1, when your sample statistics equal to the population value. That's all. Definitely when your x bar minus mu is very big, high, or your p-value decreasing. P-value decreasing. So now we give some cutoff point. We give some cutoff point. So if cutoff point is 0.05, cutoff point, and when it is, if the p-value is greater than equal to 0.05, then you accept H0. Greater than 0, this is the cutoff point, and p less than 0.05. So now you can ask me the question. Say you are solving some problem, and you get p equal to 0.95. So what is your decision? That is highly accepted. Highly accepted. Excellent accepted. If your p-value is equal to 0.06, then it is accepted, but poorly accepted. That's why p-value is called the degree of association. And nowadays, you just go to Google and just you type one sentence that is called p-hacking. Type one sentence, p-hacking. And every company is now, starting from, Google, Amazon, Flip-flop, Flipkart, all of the companies, and they are basically based on the p-hacking. With the p-hacking, they are saying my product is very good. Because if they can show that p tends to 1, that means they are okay, p tends to 1. That is called p-hacking. Okay. And that's why p is called degree of association. It's very important. Now I am coming to the point that
in terms of the accuracy, if p-value is 0.05,
people should completely reject it. Accuracy means probability 0 when there is a huge difference between sample and population. Suppose if your x bar equal to 1000, but mu is equal to 10, The difference is 990. Is it possible? So definitely you can take probability 0. Impossible. And this is one of the reasons. This is one of the reasons we go for parametric to non-parametric. This is also one of the reasons from parametric to non-parametric. Now, another thing is that say this is a very interesting part that your correlation between XY is same as RYX. We know this. We know this. There is a symmetry. But the relation UIX not equal to not equal. So that's why correlation is a problem. So again you can tell me, sir, how you can overcome? You are saying correlation is the problem. But maximum case we are solving our problem with the correlation. Don't mind. I am also solving. But the problem is, so this kind of problem we can solve by probability. Now you will ask me why? Because probability of AB not equal to probability of আমি মাংস কিনতে গেছি বিগ বাজারে, কিনতে গিয়ে মনে পড়লো পেঁয়াজ লাগবে, তাহলে পেঁয়াজ ইজ দ্য কন্ডিশন। If I go for purchasing meat, then I purchase onion. But the reverse is not true. Reverse is not true. So that's why this is called, in the machine learning, we are using this kind of association. So correlation also relationship. But we mainly trust on association. Why association? Because association can never be maximum time not symmetric. Sometimes maybe probability A equal to probability B. Sometimes is the condition. Okay. So I hope you understand the limitation of this thing. So because what is the second half? Fixation, because they are tired. Now it is 3:30. Another 15 minutes. Okay. After 15 minutes I start the visualization part with Python, and it is so simple. But after my class, anyone will start. Because I will show my PDF part, as if I will give my PDF. Okay. And when I start, so definitely I have to give the concept in Python, because in the year 2023 last, I started to learn Python. So when at the age of my retirement, so I think that definitely I have given some time, and still I am working with Python in machine learning. But it is so simple, anyone can do it. So simple. That's what I will show you. But before going Python, one thing you have to know, these 4 letters, that is called Bluetooth. Before doing this, and another rotor DOS. These are very important. I will explain. Another thing, you have to know that WWH, and finally we apply some formula to the current. So this is, if you can do this, so easily you can understand that. So what is that? So first, I started that, I applied the backtracking algorithm. Backtracking algorithm means I start from the last. That's called backtracking algorithm, Gauss elimination technique, backtracking algorithm. Okay. So what is the backtracking algorithm? For any subject, P for perseverance. You need perseverance. P for patience. for any subject. Why patience? You can practice 10 times. Because I am telling myself, when I studied class 10 level, I was not at all a student of mathematics. আমার অঙ্ক দেখলেই হয়, বাড়ি থেকে জোর করে 11-12 সায়েন্স ঢুকিয়ে দিয়েছি। আমি নেব না, আমি অঙ্ক ভালো লাগতো না। তারপর ডিউ টু ওয়ান অফ মাই টিচার প্রফেসর প্রণব কুমার সরকার, স্যার এক্সপায়ার, স্যারের ওই ক্যালকুলাস করানো দেখে আমি ভাবলাম আমাকেও করতে হবে। ক্যালকুলাস আমার একটা ফেভারিট করতে হবে। ওই করতে 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 তার মানে আমি যেহেতু বাজে স্টুডেন্ট, সো আই অ্যাপ্লাই মাই পার্সিভিয়ারেন্স। হোয়াট ইজ পার্সিভিয়ারেন্স? আই প্র্যাকটিস রাসমুখার্জি, স্টিল নাও আমি রিমেম্বার করতে পারি। ওই গোটা রাসমুখার্জি এখনো মুখস্থ। It's only for practice. How many times? At that time I practiced 5 times. At that time. And naturally after that, so many practice in the class. So automatically if you practice number of times, automatically your perfection will become. It is the automatic. আমি ভাই একটা জিনিস বুঝিয়েছি, পড়িয়ে কোন স্টুডেন্ট ভালো করবে খারাপ করবে এক সময় ভাবতাম, এখন ভাবি আমি শান্তি পাচ্ছি, আমি ঠকাচ্ছি না। বিশ্বাস করো, এখন প্রতিদিন ক্লাসে ভাবি যে আমি আমার দ্বারা কেউ ঠকছে না। ডোন্ট মাইন্ড, মানে আমি কোন ছেলে কি ভালো করলো খারাপ করলো আমি আমার 100% দিচ্ছি না, কি ভুল বলছি এইটা ভাবি, আর কিচ্ছু বলি। এবং এই ভেবে নাহলে বয়সে পাইথন পড়ে যাচ্ছে, দেখি একদিন পড়তে পড়তে একটা কি হয়, একটা মজার জিনিস, যত তুমি পড়বে তত দেখবে পরের জিনিসটা খুব কম সময় লাগছে। এটা অদ্ভুত, কিন্তু এটা না বললেও না। তোমার তো আমি ভাবি যে আমি সিকুয়েন্সিয়াল, আমি মিডিয়ান মোড জানি না, আমি স্টাডি করে নিয়েছি। আমি ইউনিভার্সিটি আনলাম না, গো ফর বাইবেলিটি। আমি বাইবেলিটি জানি না, গো ফর মাল্টিমিডিয়া, তার সিকুয়েন্সিয়াল। এবার আমি যখন মাল্টিমিডিয়া পড়াই তারও 5টা ফাইল, মাল্টিমিডিয়ারও দাঁড়িয়েছে 5-এর উপরে। এটা আজকে বলার সময় পাবো কিনা জানি না। তাহলে বোঝা গেল ব্যাপারটা কি? তাহলে এইবার আমি চলে আসি পিটু ডিপারেন্টটা ক্লিয়ার হয়ে গেল। নাও হোয়াট ইজ দিস WWH? আগে বিলিভ মি, ইন 2004-05 আমি খুব SPSS এর জন্য আমার নাম আছে, সবাই আমাকে জানে এই SPSS আসছে। IITর এক ভদ্রলোক প্রফেসর এসছে, আমি বললাম আপনি এরকম ভাবে বললেন SPSS আসছে? বলছে না তোমাকে তো সবাই SPSS দিচ্ছে। SPSS করাই, আমি স্ট্যাটিস্টিক্সও করাই। তোমার এরকম একটা বদনাম হয়ে গেছিল, এই তার থেকে বেরিয়ে এসছি। ঠিক আছে, তো বেরোতে বেরোতে আমি এই জায়গাটা চেষ্টা করছি যে এই জায়গাটা তৈরি করতে হবে। ফার্স্ট W হচ্ছে হোয়াট ইজ দিস, সেকেন্ড W হচ্ছে হোয়াই, and this H is the how. এই হাউ পার্টটা আমরা মেনলি আগে শিখি, যে কি করে সফটওয়্যার দিয়ে ডেটাটা করে দেবো, কি করে পাইথন দিয়ে রেজাল্ট পেয়ে যাবো, কি আমি রঙ নাই। কিন্তু আমার মনে হয় ইফ উই নো, সাপোজ আমি কিভাবে চিন্তা করি যে when I am studying regression, what is this? And in detail I am writing what is regression, then why regression applications, application in marketing, application in finance, application in HR, application in systems, application in machine learning. Then how we can solve? You can say, sir, I know only Excel. Better you apply Excel. I know R. Better you apply R. But you are using big data, then definitely you have to use Python. But until the data set is not big, you can use any software. It's my perception I am saying, share. Okay. So that's why this is my next point. So after how we know this WWH, then we consider DOS. Because when you go for knowing this involvement with the data. And data, there are two types of data. One is categorical data. Another is the non-categorical data. And categorical data, one is ordering categorical. Another is the unordered categorical. There is a categorical data. We can say grouping data. And S is the skeptical. Initially we know. Now, so that's why one is called grouping variable and another is called summary variable. Now we are in those are in the computer, they are doing the data mining. And for the data mining it is very important. What is summary variable and what is grouping variable. Okay. And after doing those, then we come to the theoretical part. Then come to the theoretical part. And I am telling you, on the basis of these two, the Jamovi, SPSS, R and Python, they are creating their data structure. So how they are creating? Say, we divide into two parts. This first D used for description of the data. Description of the data. Say if I say gender, so definitely I have to describe male, female. And definitely we can say gender, male, female is a categorical data, but it is unordered. We can never say male is ahead of female, female is ahead of male. It is unordered grouping. Okay. So only for description. Some data having description are also ordered. Say I am like say, brigadier, general, say major. So these are the designations in Air Force or Army. So definitely there are some ordering we are maintaining. And we are giving the questionnaire format 1, 2, 3, 4, 5. So we maintain some order. Why order? Because 1 is less than 2, 2 is less than 3, 3 is less than 4, less than 5. What are we maintaining? Basically order. So we are going for some data having ordering. Now I am giving some data, say income. Some income is 50,000. So this 50,000 we can compare with anyone. So this 50,000 data we can order. 50,000 data we can describe. And definitely why 50,000 is the distance data? Because with this 50,000 we can apply any algebraic operator. So what are the algebraic operators? We can use plus, minus, multiplication, division. Say I have 50,000 rupees and you have 70,000 rupees, I can add it, subtract, minus. So that is called the distance data. So I am telling you, there are so many examples. Just to remember the two things, that when a data y equal to mx plus c, that is a straight line. Y equal to mx plus c is a straight line. And that's why D is called interval scale. It's called interval scale data. I'm not going in detail. And another data is called origin, that is equal to y equal to mx. That is y equal by x equal to m. That is, you can find the ratio. So these are basic things. But I'm telling you, when you go R, when you go Python, they are basically concentrated on, what is continuous data and what is grouping data. Only that. Continuous data and grouping data. Only consider that. So my next session only on this data set, visualization part. So this part you have to know. So now I'm giving a sequence of before starting machine learning. Before starting machine learning, what you have to do? What you have to do? We have to do fast descriptive part, D part in detail. Already I discussed. Second thing, this D part in detail. Now this out of this D part, what are the contents? This is the main thing. What are the contents? Which things we have to study? So we start our study with probability. And this probability is based on descriptive. And after this probability, we go for random variable. So I am telling about this probability takes 2 hours class, minimum. So when I take the class in NIT Durgapur, so definitely when I start probability, I will take probability at least 6 to 8 hours. Then you will understand probability. So then I start the class of random variable. It takes at least 1 hour, 2 hours. Then I am going to the distribution. And distribution mainly for the machine learning, I am telling you machine learning, you have to study some discrete distribution. Mainly they are studying hypergeometry, binomial and Gaussian, 3 distribution, and for continuous you have to study normal distribution, beta distribution, and exponential distribution. So these are basically called theoretical distributions. And definitely these are called parametric distributions. Why parametric distribution? Every distribution having mean, having standard deviation, having all the parameters. And that's why these are called parametric distributions. And not only that, I am telling a very interesting story. Say, what is the importance of probability? So this is a pond, and this contains a number of fishes. So many fishes. Very interesting. And if I ask you, say the number of fishes, say 12,000, but you don't know, can you estimate? You can repeat the question. In a pond, there are total 12,000 fishes, but you don't know. So I will give only 10 minutes time, and you are the teacher of mathematics or statistics. So you apply your weapon means methods. Can you estimate what is the number of fishes? Then you get the idea of distribution. So then what they do, they apply, there is a very interesting distribution which is basically called parent hypergeometric distribution. Hypergeometric distribution. And apply some mathematical recurrence relation. And number 3, there some applying net means to draw the fishes and repeat the number of fishes net only twice. Only twice. And you will be astonished. I have a paper. When I was in Durgapur, I wrote a paper on this. And you will be astonished if there are 12,000 fishes originally, and using this statistical method, it will be coming 11,600. Definitely. And now this is the age of machine learning. So if I apply machine learning, maybe the error is coming. Okay. So this is the advancement of the distribution. So after applying this hypergeometry, we derive binomial. That is a discrete distribution which is very, very important. Binomial distribution. And after deriving binomial distribution, we go for Gaussian distribution and also normal distribution under some condition. That is called the limiting condition. And that's why these are called theoretical distribution. What you have to know. So after knowing this theoretical distribution, you have to go to some sampling distribution. That's the application. So what is the application? Application is t-test. Application is chi-square test. Application is self-test. And these are all parametric tests. Okay. And after using these, and these are restricted only for the 2 populations. But problem is, there are so many companies are competing with each other. So definitely more than 2 populations. So when there are more than 2 population, we consider ANOVA. ANOVA. And in case of ANOVA, there are so many segmentations, so many divisions. You can apply one way ANOVA, 2 way ANOVA, ANOVA, so many things. And after, I am telling you, after doing this, you go for regression. So regression will start after this. That means all we discussed about the diagnostic method. After diagnostic method, we go for predictive, that is started with the regression. And for regression, we have to know correlation, we have to know covariance, and so on, so on. And I am telling you a very interesting thing. When you study, just this is very interesting. This is my left hand and this is my right hand. So in the left hand there are 5 fingers, right hand also 5 fingers. And if you understand, you can understand supervised and unsupervised. Why? Because in maximum case, one dependent and one independent. Say some cases. Try to understand one dependent, one independent. What is the acceptability? Now, one dependent more than one independent. That is multiple. Now, more than one dependent, more than one independent. Logistic classification. You study like this way, then you can understand. Now, for the classification, there are so many methods. Now, so, now after the tea break, what is my agenda for this next session? Python. And since you don't, I know that some knows Python, some doesn't know Python. No need to know Python, because Python is so simple. I will show you. I will take some database. And this database containing some continuous variable and some categorical variable. Clear? This is required for Python. And out of this continuous variable, some is the integer and some is the decimal float. There is a decimal point. So these are first case. That means there are some variables and this is a database. So first we discuss this. So what is my database? Now since Python is a huge language and it is derived from some object-oriented C, C++, so definitely it is based on some functions and library packages. That's all. And function library package is already inbuilt. If we give the mean, automatically calculated. No need to give the formula, because that formula is already inbuilt. If I write on the core, correlation will calculate. Okay. So similarly, so before going for any analysis, first I have to check that how many variables are integer variable, how many variables are float variable, how many variables are categorical. This is the first question. Why? Because we can find the correlation only on integer and float. That you know. So now, according to the visualization part, first we go for what is the pattern, that is the distribution. Distribution of continuous variable. This is the first question. Distribution pattern from the data set. Second data set, so when you go for distribution, so that is basically based on univariate data. When you go for distribution, that is basically based on univariate data. So after doing this distribution, number two, we go for joint distribution. So joint distribution means there are two variables. That's the bivariate data. And after joint distribution, when we consider correlation, there is a pairwise distribution of the correlation. So this is, I will show you after T, this part. Okay. And definitely for doing this, I need some library for Python. And mainly Python using the two types of library for this. Actually, three types of library. They are using matplotlib, Seaborn, and pandas, simple plot. Okay. So they are using library. And when there is a very interesting thing, you have to maintain a flowchart. When you learn any language, you maintain some flowchart. So in the last week, I taken some classes for costing institute. So one of the students told me, sir, we don't know nothing about R. So can you give some flowchart by which we can learn? Very interesting. Very interesting. So in this way, I will give you a flowchart of Python. Then easily one by one you can suppose not for all, I am telling you about for the beginners. Okay. So this is the way. So I am telling. But today I will not get time because I have to show this. Because flowchart for this imports for some library. Import library. This is the first thing. Second is this is called, very interesting. Why Python is simple? Already I have prepared all templates for machine learning. That's why Python is easy. If you go to Google and if you write that I need the template for regression, and after getting the template, what you do that? You put your data set. Automatically. So why I am not learned, you tell me. Because all template is available. You template of super vector machine, template of PCA, template of Fleming's clustering, template of all MCDM optimization, all templates are ready. So what I am doing, suppose I don't know MCDM, then first I study MCDM. And this is the set of Cs. And then I go to the template, and then I put my data automatically. This is my process. In this way, I studied non-parametric in Python. Already I studied. Just make some template. What is the template? That's what I am telling you. What is the template? First template, step one is the import library. So initially, when I was still now in the beginner, I don't know what is Seaborn. Seriously. Because no teacher. So one day I go to the Google and I write that visualization distribution plot using Python which package. Understand? Import Seaborn. Yeah. Then they are giving them some data. Then I understand step 2 means data. Step 2 means data. Is it charity? Thank you. After T, sorry, thank you.